Another design to be aware of is, it sometimes gets called the crossover design, and this is for the situation where it's possible to give more than one intervention to the same individual or to the same unit if you're not studying individuals. In the crossover design you would do that in a random order. So it might be that you can give the same intervention in time, or it might be that you're studying different parts of the body, right and left, and you can give it at the same time. But if we assume we're giving it in time, then it's got to be an intervention that lasts for a bit. It doesn't have a permanent effect, and then you can give another intervention that isn't influenced by the first one. And that often reduces variability in the data because we're sort of taking out the between individual variability, and we can compare the interventions within the individual or within the unit, and reduces the variability and gives us a more efficient analysis. And sometimes that can be called a within subject design because we're taking different interventions within the same individuals, or sometimes they'll get called subjects. So an example of that, if you imagine an experiment to see whether mice preferred the tastes of saccharin or salt in their water. We're going to study mice by the cage rather than individuals and just measure how much of each of these fluids they drank in each of 4 cages. But rather than just sort of have 2 cages on one fluid, 2 cages on the other fluid, it's possible to sort of study each cage on both of the fluids. So you give one fluid to the first cage for a bit and then switch over to the other fluid, and that can sort of, by doing that, if there was a particular effect, correlation between the animals in, say, cage 1, then by giving them both of the interventions it takes that out. And so we would do that. But the key thing about a crossover study is you give it in a random order. You don't always give saccharin first, salt second. You mix it up a bit just in case there's any biases due to the order effect. Definitely think about the crossover design if you're going to give different interventions to, say, an animal over time. Don't always do it in the same order unless there's a particular reason to. Another design that's frequently appropriate is what can, in statistical terms we talk about this as a repeated measures design, where you want to measure something repeatedly over time and see how the effect of an intervention changes over time. And in that case, say we're measuring in mice again, we might be measuring the same thing on the same mouse but at different time points. So there's potential for correlation in the observations on the same mice, and that needs to be taken into account. So the experimental unit, it's important to realise it's the mice. It's not, so you've effectively got 6 mice, 3 in each group here. So when you come to analyse the data, it's 3 and 3. It's not, you've not really got 12 and 12. So you can't consider these observations as independent. The thing, when you're planning a repeated measures design, it's quite useful to think about what your objective is in advance. I mean, is it to look at each of these time points and say, is there a difference, or is there one time point that's of particular interest that you're going to analyse? Because if you want to analyse each of the time points, there's sort of multiple testing to consider, because you're more likely to get a statistical result if you've got multiple things to analyse, which might confuse the interpretation. And you do need to be careful with the statistical analysis. You really don't want to think that these 12 observations that you take are independent and, say, do a t-test just lumping them together in some way.